Hi friends, good morning to all of you. Today our topic is the basics of remote sensing and its essential components. Remote sensing is the recent science and technology that have been used for collecting information about an object, area, or phenomena without any physical contact. For example, I am observing an object without any physical contact. I am describing its characteristics. So it's a part of the remote sensing. There are several scientists has given some basic definition of this technology, like Savins, in 1997 stated that remote sensing is the science of acquiring, processing and interpreting images that record the interaction between electronic energy and the matter. So what Savins says, that is a science of acquiring, that is collecting information, processing information, interpreting information, that is the interaction between the electromagnetic energy and matter. So basically we can say it's a science and technology of collecting, processing and interpreting of the information without any physical contact. So now going to understand the components of the remote sensing. What are the major components? In remote sensing, the practice comprises an interface concerning incident radiation and the object of interest. There are several components that involves in this remote sensing process. First, the source of energy. There should be a source of energy which illuminates the electronic energy of the object of interest. Second, interaction with the atmosphere. This energy comes to the Earth surface and it interacts with the atmosphere which is laying above the Earth surface. Interaction with the Earth objects. Object, after interacting with the atmosphere, the energy comes to the Earth surface and interact with the object. Fourth, radiation energy. Radiation of energy recorded by the sensor. After reflecting back from the earth surface, the energy recorded by the sensor. Fifth, transmission, reception and interpretation. After this energy transmitted to the antenna and it recorded by the antenna, after that interpreting the data that is collected about the radiation energy recorded by the sensor. Next is the application. After interpreting of the images or the data acquired by the sensor, it will be useful for which purpose? It will be used for the purpose of our application, like in which purpose we are going to use. Next, coming to the types of remote sensing. Basically, there are two ways we have classified the remote sensing technique. One is the based on its wavelength region. Based on the wavelength, there are three types of remote sensing techniques. First is the visible, in visible remote sensing, the portion of the wavelength measured by the remote sensor device, that is in visible spectrum, which is ranging from the 300 nanometer to 3000 nanometer. So, the information will be acquired within these wavelength regions. Then we can consider as the visible remote sensing. So there are some basic advantages of this visible. Also, it is also known as the optical remote sensing. What are the advantages of this technology? Easy to interpret of the data, and the large areas of the ocean can be quickly scanned. Easy to interpret, and large area coverage. Of ocean and earth surface features. There is some disadvantage of this technology, of this remote sensing, that we cannot acquire information at night. During night, it is not possible to gathering information through this visible or optical remote sensing technique. Second is the thermal remote sensing. In thermal remote sensing, we are collecting information, that is, in thermal remote sensing, we are collecting information in the two wavelength region. One is 3 to 5 micrometer and another is 8 to 14 micrometer. So when the energy will be captured by the sensor within this two wavelength band, then we can consider as the thermal remote sensing. The basic advantage of this thermal remote sensing, it is simple to operate and can be installed in the small aircraft. And the infinite systems are moderately priced. That is the low cost. And some basic disadvantage of this thermal remote sensing also, that is, it cannot penetrate the clouds, and the understanding of the thermal data, that is, the expert is required. The person, those who have not any knowledge about the remote sensing technology, it cannot be explained the thermal remote sensing data. Next one, last one, is the microwave remote sensing. In this remote sensing technique, we are gathering information from 1 millimeter to 1 meter region. We are acquiring information of the data from 1 millimeter to 1 meter of the electromagnetic spectrum, and this is called the microwave remote sensing. And the system has the capability to collect the information at day and night, and it can also penetrate the cloud, And disadvantage of this is the very costly. Also, expert is required for interpreting the information or acquiring information from the remote sensing data. And there are another way of remote sensing types is the source of energy. Based on the source of energy, there are two types of remote sensing. One is the active and passive. So what is active type and what is the passive type? In passive remote sensing, the source of energy, there is a natural source of energy. There is a natural source of energy. What is our natural source of energy? Sun. Therefore, we are taking information based on the natural source of energy, then we can consider it is a passive remote sensing. Whereas in active remote sensing, the sensors have the own source of light for illumination. So this is called the active remote sensing. Next, another important component of the remote sensing is the platform. What is the platform? Platform is a physical device where the remote sensors are mounted. For example, the sensor is carried by the satellite. So satellite is a platform because the sensors are mounted on the satellite. It could be fixed, that means steady, or it could be mobile. So there are two types of platforms are generally used in these technologies. One is the fixed platform and another is the moving platform. However, before going to understand this platform, we should consider there are four basic important things for the platforms, like distance between the sensors and object, sensor and object, what will be the approximate distance between the sensor of object. So we have to use this platform. What is the purpose of this use of this data? So based on that, we have fixed the distance between the sensor and object. Second, periodicity. Periodicity of the image acquisition. After what time later we are taking the information of the object from the same viewing point. Third, timing. What is the time of acquiring information? And fourth is the location and extent. That is it the acquiring information at the North Pole or South Pole? And what will be the extent? So these are the basic component, basic aspects which will be considered during the fixing of the platform. So as I earlier stated that there are two types of platform. So basically, one is the steady platform, and another is the moving platform. Steady platform, that means it will be fixed in a particular area. It will be there is no movement of this platform. And moving, it can be carried at anywhere. So it is also known as the ground-bound platform. It is also classified as the cherry-based and the tripod-based. Suppose we would like to take the information from a particular object by stationing the platform on the ground. It is known as the ground-bound platform, that can be cherry-based or the tripod-based. But in moving platform, there is a airborne, where aeroplane is the or aircraft is the platform, and the spaceborne, like satellite, launching of satellite, we are fixing the sensor and gathering information. So this is called the spaceborne. In the airborne, earlier we are using the balloon to collect the information. So balloon is a one type of platform for gathering information. And recently we are using the aeroplane or aircraft. Whereas in the spaceborne, there is two types of classification. One is known as the sun synchronous and another one is the geostationary. I will come into later details about this platform. The next components of the remote sensing is the sensor. What is the sensor? Sensor is a device that receives electromagnetic radiation and convert into signal that can be recorded from the Earth surface objects. And the sensor is being mounted with the satellite. As we studied earlier that there is illumination of an energy and it interact with the Earth atmosphere. After that it will interact with the Earth object and radiating back to the upper atmosphere where the sensor is mounted, and it collecting this or radiating this information, collecting this radiation, and it converts into the signal. After that it will be processed and converted into the data or images. So in remote sensing there are different types of sensor used. First one is the passive sensor. In passive sensor, that is recorded light where the natural source of illumination, based on the natural source of illumination. For example, sun is the source of energy that you know. It will come to the Earth's surface after the reflected back by the upper atmosphere where is the sensor is mounted. So sensor recorded with energy. This is known as the passive remote sensor. For example, in like Landsat data, in India, IRS remote sensing. These are the example of the passive sensor. Now active sensor. Here the sensor having its own light for illumination. Sensor illuminate its light